Have you ever actually stopped to think about what determines the value of that cash sitting in your wallet right now? I mean, why does a dollar, a euro, or a rupee buy a certain amount of groceries today, but might buy you way less next year? Well, welcome to This Explainer. Today, we're going to unpack one of the absolute most fascinating, controversial, and foundational concepts in all of macroeconomics. We're diving into the quantity theory of money. We'll be looking at it specifically through the lens of Professor Irving Fisher, and then we're going to look at how real-world economists completely tore his perfect mathematical model apart. It's a classic setup and knockdown story, and it's honestly going to change how you look at the entire economy. So, here's our game plan for today. We'll kick things off with a quick intro to quantity theory. Then, we'll break down Fisher's famous equation of exchange and spend a minute truly understanding supply and velocity. After that, we'll expose the classical assumptions holding the whole thing together, right before we watch the critics strike back. Let's get into it.
All right, Section 1, Intro to Quantity Theory and its Historical Roots.
To give you a little context here, the quantity theory of money is actually the oldest theory we have for figuring out the value of money. The whole idea was first tossed around way back in 1566 by a French economist named Jean Bodin. Over the centuries, heavy hitters like John Locke and David Hume tweaked it. But it wasn't until 1911, when Professor Irving Fisher published his massive book, The Purchasing Power of Money, that this theory was really locked down into the formal transaction approach we still argue about today. So what is the theory actually saying? The core thesis is this. There is a direct, proportionate relationship between the sheer quantity of money out there and the general price level. In totally plain English, if the money supply goes up, prices go up by the exact same proportion. And on the flip side, there's an inverse relationship with the value of money itself. So if prices double because there's suddenly twice as much cash floating around the system, the actual purchasing power, the real everyday value of your money, literally gets cut in half.
That brings us to Section 2, Fisher's equation, also known as the equation of exchange.
The theory sounds intuitive enough, right? More money chasing the same stuff means higher prices. But Fisher wanted to mathematically prove it. And what's super interesting here is how he translated messy human behavior into a flawlessly clean equation. mv plus m prime v prime equals py. Okay, stick with me, let's break this down gently. M is just the hard money in circulation, and v is its velocity, basically how fast that money changes hands. M prime and V prime are just the exact same thing but for credit money, like bank deposits. On the other side of the equal sign, P is the price level and Y is the physical volume of goods produced and exchanged, essentially real GDP. So if you multiply money by its velocity, you get the total money spent. Multiply goods by their price, you get the total value of things bought. Total money spent exactly equals the total value of things bought. Make sense? Let's actually run the numbers to see Fisher's point in action. Imagine an initial state where we have 100 units in money and 200 in credit. If we assume velocity and the volume of goods stay completely flat, the math naturally spits out a price level of 4. That makes the value of our money 1 over 4. Now, watch what happens when we simply double the cash. Money jumps to 200, credit jumps to 400. Run that exact same equation again, and boom, the price level precisely doubles from 4 to 8. And the value of your hard-earned money? It drops exactly by half down to 1 over 8.
Moving right along to Section 3, Supply and Velocity. Let's put some real-world context on this. Equations can feel a bit, abstract. So let's ground the left side of that equation, the supply and velocity part, in a totally relatable scenario. What actually is velocity? Imagine a guy named Ram has a single 1 rupee note. Step 1, he buys a pen from Shyam for that rupee. Step 2, Shyam takes that exact same note and buys some sweets from Mohan. Step 3, Mohan turns around and uses it to buy ice cream from Sohan. In that short period, that one single piece of paper just settled 4 entirely different transactions. That means the velocity of that specific rupee is 4. It literally did the work of 4 separate notes. And this is a massive takeaway. Money supply isn't just the cash the government prints, it's the cash printed multiplied by how frantically we spend it.
When you map all this out, you get Fisher's grand conclusion. You end up with this perfectly straight 45-degree angle charting the equilibrium where money supply equals money demand. Because Fisher assumes everything else in the world is held perfectly constant, he creates this incredibly strict one-to-one mathematical relationship. If the quantity of money demanded doubles, the price level is forced to double in exact proportion. It is so perfectly neat and tidy.
But as we'll see in Section 4, maybe it's a little too tidy. Let's look at the classical assumptions, the scaffolding holding this whole model up.
Seriously, to make this perfect 45-degree line work in reality, Fisher relies on a fantasy world of very strict classical assumptions. First off, he assumes velocity never ever changes. Second, he assumes the economy is always humming along at 100% full employment. Because of that, his third assumption is that the total volume of trade, the amount of stuff we make and buy, never fluctuates. But the wildest, boldest assumption of all, that money is strictly, 100% of the time, just a medium of exchange. Fisher literally built a model assuming people never ever hold on to money simply to store value. You get paid and you instantly spend it. No savings, no mattresses stuffed with cash.
And that is the perfect segue to Section 5, the critics strike back, reality versus the model. This is exactly where the perfect textbook math violently collides with the messy, unpredictable reality of the actual economy. Enter John Maynard Keynes. Keynes delivered an absolutely brutal critique of Fisher's life's work. He said, and I quote, "The quantity theory is a truism which holds in all circumstances, though without significance." Ouch. What he meant was, sure, MV equals PY. Total money spent will always equal total money received. Even a toddler knows that. Keynes was pointing out that it's just a mathematical identity. It tells us absolutely nothing about the actual mechanics, or why the supply of money changes, or which factor actually forces the other to move. It's like saying water is wet without explaining rain. From there, post-Keynesian critics unleashed a rapid-fire dismantling of the whole theory. First, those assumptions? Totally unrealistic. Velocity wildly fluctuates in the real world. Second, the variables aren't sitting in isolation. A sudden change in money supply absolutely can change the volume of trade. Third, it completely ignores the obvious fact that money is a store of value. People do hoard cash, especially when they're scared. Fourth, it completely fails to explain trade cycles. Think about it. During a severe depression, you can pump in all the money you want, but prices won't necessarily rise because the velocity of money drops off a cliff. People stop spending. Finally, critics pointed out a massive technical flaw. Fisher inconsistently multiplies a stock concept, money measured at one static point in time, by a flow concept, velocity measured over a long period. Mathematically, a big no-no.
So the whole disagreement really boils down to one massive philosophical paradox. Fisher believed the price level was just a passive factor. It just sat back, blindly reacting to the money supply, never actually driving output or employment. But the critics fiercely argued the exact opposite. They said the price level is a highly active factor. Think about it. When prices go up, businesses make more profit. Higher profits cause them to actively ramp up production, increase trade, and eventually demand even more money. The price level isn't just a passenger, it's driving the car. Which brings us to the end of our explainer today, and I want to leave you with something to really chew on. If we accept what the critics are saying, that money isn't just some fleeting medium of exchange, but a vital store of value that we hoard during the bad times and spend wildly during the good times, does Fisher's perfectly balanced equation completely fall apart in the real world? Or, despite its flaws, does it still hold the absolute foundational key to understanding the inflation we see today? It's a massive debate that economists are still arguing about right now. Thanks so much for joining me for this deep dive. Keep questioning those textbook models, and I'll catch you in the next explainer.